Hello everybody and welcome back to RSW Tutoring. Today we will be taking a look at recursive sequences and sigma notation. So students often tell me, well, recursive sequences are complicated, they're challenging. Well, I really disagree with that fact. I think that arithmetic and geometric can be more challenging depending on their context, but nonetheless, in this video, I will make recursive sequences very, very clear. Let's begin by talking about what a recursive sequence really is and what makes it so simple, in my opinion. Well, a recursive sequence uses the previous term or terms to find the next term. So all we have to do is establish a relationship between a previous term to find the next one. And so the general term includes the notation u to the n minus 1, which indicates the previous term, or pt. Okay? Now, I will illustrate this in an example, and this will really help out once you see it. So let's just say a general term for recursive sequence is un 2u to the n minus 1, which is our previous, so 2 times the previous term, minus 3. And our starting term would be u1 equals 1, right? And we are asked to find the next two terms, correct? So how would we go about doing this? Well, this is the beauty of recursive sequences, right? All we have to do is take our previous term, which is given in this problem, and substitute it in the formula to get the next term. So our second term, u2, would be 2 times 1 minus 3, which would give us negative 1. And then how do we go about finding the third term? Well, you guessed it. We take this number, we plug it back into the same formula, and we get 2 times negative 1 minus 3. That gives us negative 5. Very easy, very simple. That is all you have to do in any recursive sequence case. Now, we will do some more examples to solidify our knowledge, but for now, I want to really understand how, or I want to explain to you how we can extract the general term recursive sequences from a given set of terms. For example, let's say we have 500, 100, 20, and 4, and this goes on and on, let's just say. So what are we doing here? Well, if you watched the last video, you'd know that we're multiplying this by 1 over 5, or we're dividing by 5. And in order to establish a general term recursive sequence for this, well, we just have to create a relationship between the previous term, 500, and this term. So what we're doing is we're simply multiplying by 1 over 5 each time we go from the previous term to the next term. So our general term sequence would be un is 1 over 5 u to the n minus 1. But what students tend to forget and lose communication marks on is when they don't put the first term. And the first term in this case would be 500. And this is very important because how do we know where we're going to start? How do we know we didn't start at 2,500 or at a number bigger than that? So that is why we have to specify exactly the starting point for a recursive sequence. Very, very important. Now let's do some further examples to consolidate our knowledge. Let's do -2, -4, -6, -8, etc. How do we go about finding a recursive general term for this sequence? Well, we obviously know that we're just subtracting 2 each time from the previous term. So therefore, what this would be is our general term would be u to the n minus 1 minus 2. Simple as that. And our first term would be -2. Very simple, very easy. Let's take a look at another example. Let's take a look at this one. 1, 4, 16, 64, and 256, okay? How do we establish a general term recursive for this? Well, each time what we're doing is we're multiplying by 4. So again, it's the same concept. What do we have to do to the previous term to get to the next term? Well, we have to multiply by 4. So you literally just have to write that down. 4 times u to the n minus 1, where u1 equals 1. And that is it. It's that simple. Let's move on to another example. Let's just say we have 52, we have 5.2, we have 0.52, and we have 0.052. What are we doing here? Well, we're multiplying by 1 over 10 each time, right? So what we have to do here is in our general term, we basically say, well, we have to multiply by 1 over 10. So 1 over 10 times u to the n minus 1, where the first term, right, is 52. It's the same exact ideology. Now, it's not always going to be the same, so that is why we're going to do some more challenging examples coming up. Let's do one more simple one, and then we'll do the challenging question. So 14, 19, 24, and 29, etc., etc., etc. Obviously, what we're doing here is we're adding 5, so our general term would be, well, u to the n minus 1 plus 5, and that would be our general term, specifying that our first term would be 14. And that would be the answer to this question. Now let's take a look at the challenging questions. Let's look at this sequence. 2, 3, 6, 18, 108, I believe it is, and 1944. Let's take a look at this one. So this one is a bit more challenging. Why? Because it's not your typical recursive, but it is pretty simple to understand once you see it. So what we're doing here is we're taking 2 and we're multiplying it by 3 and continuing this pattern over and over and over again to get the next term, because 2 times 3 gives us 6, 3 times 6 gives us 18, 6 times 18 gives us 108, and on and on and on. So then, how do we write this in recursive terms? Well, here's where we get introduced to a new concept. How do we write the second previous term? Not just the first one, but the second one. And how we do that is we say u to the n minus 1, which is our previous term, multiplied by u to the n minus 2, which is the term that proceeds right after it. Correct? And then when we analyze our starting points, we have to say that u1 equals 2 and u2 equals 3, because now we have 2 components of the recursive sequence. But then again, it's not that hard to understand. Well, un minus 1 is the first, un minus second, and if there was a third option, for example, if we can multiply all of these, and that would be the nature of the sequence, then we can add a un minus 3. So it's not hard, but these are the types of questions that you tend to get on tests. Let's do the last one. This one is most likely the hardest one to notice, but it is worthwhile doing. So we have 1, 2, 6, and 24, and this sequence proceeds. Now, we're not adding a continuous term. We're not multiplying by continuous. We can't split it up into factors or multiples. So what are we doing here? Well, let's take a look. This has to do with the term number. So let's just say the term numbers, let me just write them down here so we can have an idea. And if you are able to notice this, then you are on a very, very good path in terms of preparation for your test, because all you're doing here is, if you see the pattern, you see it. It's just there. So in terms of what we have to do, 2, if you look here, 2 times 1 gives us 2. 3 times 2 gives us 6. 4 times 6 gives us 24. You see that? So what are we doing here? Well, we're taking the term number, right, and multiplying it by the previous term to get the next term. So how are we going to put that in context? Well, our general term would be the term number, any term number, right, multiplied by u to the n minus 1. And that's exactly what we're doing. Where our starting point, u1 equals 1. So that is pretty much it for our recursive video. And if you have any questions, please leave a comment and let us know what we should do, if there's anything more we should focus on. But please stay tuned, because the second part of this video will be coming out very shortly. It will be called Sigma Notation, and it would be beneficial if you also watch that as well.